Welcome back. Imagine you're using an app. You click download, and suddenly the whole screen freezes. You can't scroll, you can't click back, and it's like the app died. This happens when we write synchronous code for tasks that take time. The app is stuck on one line of code waiting for the internet to respond. In Flutter, a frozen app is a deleted app. What we need to say: go do that task in the background and let me know when it's finished. Think of it like ordering coffee. You don't stand at the register staring at the barista until the latte is done. If you did, the line behind you would grow forever. Instead, the barista may give you a buzzer. You go, you sit down, you check your phone, and relax. The buzzer is what Dart calls a future. It's a promise that something will be delivered later on. When the buzzer goes off, you await your coffee and then continue throughout your day. This is your UI thread. It's responsible for every single swipe and tap that the user does. If you put a heavy task like a 5-second download directly on this line, everything stops. The highway blocks. So for example, if you downloaded something over here and you waited up to here, then you wouldn't be able to tap, scroll, or nothing would be animated throughout the duration until that download is complete. To fix this, we use Async. When we use Async, we create a detour. We tell that heavy task, hey, go over there and run on your own time. The main thread keeps moving on its own. The user can still scroll, click buttons, and play animations. Then once the background task has been completed, it merges back into our main line with the data. This is the secret to why professional apps feel snappy even when they're doing massive amounts of work behind the scenes. Watch how we handle time. We use two keywords, async and await. Let me delete all of the code from our previous episode. Let's start with a function that downloads photos. So for this, we need to look at a new data type. We call it a future. Inside the future, we want to return a string. And our function's name should simply be something like download photo. We're not taking any parameters, and we're defining this function as async. Inside our function, we want to simulate a 3-second delay. So normally when you download something, there'll be a slight delay. So we're simulating a 3-second delay. The way we do that is by simply await future.delayed, and we pass in a duration for seconds 3. So you do not need to understand what this piece of code does. You do not need to know what this piece of code does keyword by keyword, but basically understand that when Dart hits this line, it will wait for 3 seconds before continuing on to the next line. So if I were to add a print statement here, it would wait 3 seconds and then continue on to the print statement. What we want to do is not print, but we want to return something called photo downloaded, for example. So when we call this function inside, obviously, our main function, we call this function inside the print statement, we write download. So what you're getting here is just a future. Futures work exactly the same as to how promises work in JavaScript. So basically a future is just this function's way of telling that, hey, I'll have the data ready for you in a bit. Until then, take this. So it's passing an instance temporarily until it has the data. But since we're printing immediately, then we're just getting the future. We're not actually printing the data. So a fix around to this could be simply calling the function, but inside the function, instead of returning this data, we print the data. Now, if we call this function, for this to work, we obviously have to remove the return data type because string is what this function would return. And since we're not returning anything, we remove that for now. And if we run this program, nothing appears for a bit. That is for the exact 3-second duration, and then we get photo downloaded. So we get this piece of code. So we get this after 3 seconds. Now let's go back to our string and create a proper demonstration for this. So instead of printing this, again, we want to return this. And let's give a real world example. So the first thing that your program would print something like click download. Then you click download, and once you click download, you want your photo to be, in this case, you want your photo to be stored in a string because we're returning a string. But ideally, your photo would be stored maybe in a URL, which would be a string, or you would download it. So we're going to await this function. So we're going to wait for this function to return us with a value. And then finally, what we want to do is we want to say that we simply just want to display photo. So in this photo, instead of passing on photo downloaded, we could simply just say display photo data. You'll see that this await keywords gives an error because await keywords cannot be used independently without async keywords. Async is what makes your code asynchronous, which means not blocking. So it will allow processes that take long time to run in the background while other synchronous processes that run immediately run in the foreground. What await does is it blocks it. So it blocks this piece of code, meaning it waits for download photo to return something before continuing on with this program. If I did not await here, this would simply skip downloading photo, print display photo, and then try to download the photo. So if I run this program now, firstly we get click download. After a 3-second delay, we get display photo data, which is this print statement here. Let's go over that. Inside the main function, we added the async keyword so we can use await. When this code hits the await download photo, it pauses this specific function, pauses everything, but it keeps the rest of the app alive. So everything else that may be running in any other function will be kept alive. 3 seconds later, this data arrives and we move on to step 2, which is displaying the data. But what if the internet fails? In the async keyword, we wrap our code in a try-catch block. If we try to get the coffee and if the machine is broken, we catch the error so the app does not crash. It's like having a backup plan. So in case that this photo fails to download, we don't want to crash the entire app. So we simply put this in a try-catch block. So we try to download this photo, and if that is not possible, then we catch the error. We catch the error into the variable e, and we simply print the error. Now this statement needs to go inside the try-catch block, and there we go. If we run this program, it will run like how it did right before this. But the added functionality is that we have error handling. So in case that this function was not able to return this data, the catch block would catch the exact error that went wrong, and it would print that error out. It would print that error out and continue on with the program without crashing the entire application. You've now looked at the art of waiting in Dart. Your apps will now feel more smooth and professional when you finally start coding them. Your homework for today is to go to Dartpad and write an async function that simulates logging in. Give it a 2-second delay, print checking credentials at the start, and welcome users at the end. In the final episode of this series, we go to the absolute limit, isolates. We're going to learn how to run 2 things at the exact same time using multiple CPU cores. I'll see you in the final episode.